Good evening, students. Welcome back. We are discussing reactions of alcohols and phenols, and we are talking about the cleavage of carbon oxygen bond. But we are discussing cleavage of carbon oxygen bond. Students, we have already shown a very important reaction. Two reactions we have told you which are very important for the exam. We told you we can distinguish students primary, secondary and tertiary alcohols. There was a question distinguish distinguish primary, secondary and tertiary alcohols. What was our answer, students? What test was done? What is the name of the reagent we have used?
Lucas reagent test.
Very good.
Lucas
Yes, that is the correct answer. Lucas reagent test. What is question was what is Lucas reagent, student? Concentrated HCl and ZnCl2. When you add this in tertiary alcohol, student, in 3 degree, you get immediate turbidity.
सर आप रिपीट कर दो सॉरी सुना नहीं
If you add
क्या पूछ रहे थे आप
if you add Lucas reagent to tertiary alcohol, 3 degree alcohol, there will be immediate turbidity. Immediate turbidity will be obtained in the test tube. And if you add Lucas reagent to 2 degree alcohol, 2 degree alcohol means secondary. This is our tertiary alcohol. This is our secondary alcohol. Then it will take about 10 to 20 minutes. And you may have to little bit heat it. Turbidity appears. So it's a slow reaction, primary, no turbidity. So this way we can distinguish. This is a very important question. Distinguish primary, secondary and tertiary alcohols have been asked many times, student. So no turbidity at room temperature. Even if you don't heat it, it will take 10 to 15 minutes. I mean, it will come, but it is a slow reaction. Here at room temperature, nothing. So by this method, we could distinguish 3 types of the alcohols. As you know, the reactivity order for such reaction is 3 degree, greater than 2 degree, greater than 1 degree. You know the reason for that also, students? The reaction was proceeding through carbocation mechanism. And you know what is the stability order of the carbocation? 3 degree carbocation more stable than 2 degree, 2 degree more stable than 1 degree. So we can write in the paper, and therefore that's all we have to write in this, nothing more. This reaction we have discussed last time. Important question. In our lectures, we are talking of questions which are very important for the exam, students. And we have told you how when dehydration reaction, we have shown the mechanism of dehydration also. Acid, when we add acid to the alcohols, what happens, students? Concentrated sulfuric acid at 443 Kelvin or H3PO4, what happens? The dehydration takes place, loss of water takes place, and what you get are alkenes. The reaction was discussed. This is the first. There was a question which was asked in the paper. Explain the mechanism of acid catalyzed dehydration. Acid catalyzed dehydration of ethanol. Important question. It was given 2 years back also in the board. We have already discussed 3 steps for this. Protonation of the alcohol, formation of the carbocation and deprotonation. I hope you are so confident about it. You are aware of this
Yes,
mechanism?
sir. Yes, sir.
Okay. You have in your notes, so no difficulty. I'm just giving you the questions which are important. They can be asked and repeated again. This question was 2 marks in the Cbse papers. Again, there is a possibility that such questions will be asked students. Wherever the mechanism is involved, which is involves carbocation, you know that the reactivity order will always be 3 degree, more than 2 degree, more than 1 degree. Now we're coming to more important reactions of the alcohol student. What are those reactions? We are talking about the oxidation of alcohol students. Oxidation. What do you mean by oxidation student? What is the meaning of oxidation? What we are saying, this is our alcohol. This is our alcohol student. This is H here, and there are H here, there is a O, there is H. Then there can be some more carbon or whatever it is. This is the part where we are going to do the oxidation. Here you can see that there is a hydrogen. There is a hydrogen student, and this is our oxygen. Yes, this
Yes,
is
sir.
the carbon. This is the carbon to which OH group is attached, student. This is the carbon to which OH group is attached. Oxidation will mean what? Oxidation is, what is the oxidation classical definition? We say loss of hydrogen. That is what oxidation is. That hydrogen will be lost, student. Where is the hydrogen which will be lost in this case, student? You can see that this hydrogen, this hydrogen. If this is lost, student, what is the result of this? What will be the result of this? This bond
Reagent.
has to break, and this bond has to break. This hydrogen means this bond, this should break and this should break. These two hydrogens will go, then what will happen? You will get a carbonyl compound. What will be the result? Carbonyl compound, student. Aldehyde or ketones. You are aware of it? You are aware of the aldehyde or ketone, students? This is example of oxidation. And you can see this is my alpha carbon, student. This is the alpha carbon. So what you have basically to show it, this is the alcohol part. This is the alpha carbon. I mean, next to oxygen. So what is important? There should be hydrogen present here. Then only this reaction is possible. Alcohol will always have H. Oh, this is oxygen. This always has H. But this should be there, H, so that this bond cleaves. And what will happen if this bond breaks? This and this hydrogen is lost, student, and you will get carbonyl compounds. The one of the problem is that for oxidation, you will always need oxidizing agent. Yes or no? 1 point. You will need oxidizing agents. ठीक है? Yes or no? How will it not going to oxidize by itself? There will be some oxidizing agent, student. There has to be some agent to do that. And you know what type of oxidizing agents you are using in chemistry. What type of oxidizing agents commonly which you are using in the chemistry? Can you name some of the oxidizing agents which are commonly used? Commonly used, students, you are aware of them. You are aware of the oxidizing agent. You have heard about potassium permanganate, or you are aware of KMNO4. You are aware of K2Cr2O7, student. These are some of the oxidizing agents which are used commonly in the chemistry. You can use acidic or alkaline, or you can use acidic dichromate. These are some of the common oxidizing agents. They are strong oxidizing agents. They are strong oxidizing agents. You are aware of them. You are aware of them. So what they do? Why they are acting as oxidizing agent? You know, when we will teach you transition elements, you will see manganese here is in +7 oxidation state. So it is in a very high oxidation state. It will go to a lower oxidation state. Therefore, it will gain electron. It will gain electron. And once it gains electron, what will happen? It will act as an oxidizing agent. It will oxidize. Similarly, potassium dichromate, we can find the oxidation number of chromium here. You will see it is in a higher oxidation state. This is +2 and -2, the +6 oxidation state, +6 oxidation state. So these transition elements which are present in higher oxidation state, they will act as oxidizing agent in acid or basic medium, or even in neutral, they may act as an oxidizing agent. The trouble will be this. If I have RCH2OH, this is my primary alcohol, 1 degree. Yes or no? Is it primary alcohol, students?
Yes, sir.
There are hydrogens present at this carbon. Yes or no? This is
Yes,
alpha
sir.
carbon. The carbon next to the OH group. Next is called beta carbon and gamma, like that. Now there is a hydrogen here. Or if I show it like this, student, to you, this is looking like this. RCH, you have O and you have H. So that means if I will do the oxidation, there is a chromium trioxide also which acts as an oxidizing agent, which you will see in. These are all examples of the oxidizing agent. So you will add an oxidizing agent. If I say I am adding any of these, what will happen? This hydrogen is
Hydrogen
gone.
lose.
This hydrogen is gone. What will be the result of this, student? RCH double bond O. What is this? What is the name of this compound? What is this? You have got aldehyde? Yes or no? There is an
Sir.
aldehyde.
Yes, sir.
But the problem with this is that this aldehyde can undergo further oxidation. If the oxidizing agent is strong, what will it do? This will further oxidize it. There is one hydrogen here. What is the product of that? Then it can oxidize it to form a carboxylic acid. What is this?
Carboxylic acid.
Carboxylic acid can be obtained, student. You know that oxidation may not stop here. So primary alcohols can undergo oxidation to aldehyde and then to carboxylic acid. So if we want to stop at this stage, if we want that oxidation should stop at this stage, we have to use a weaker oxidizing agent. And these are strong oxidizing agents which we are talking about. So we will use some oxidizing agent which will stop the process at aldehyde state. We will tell you the name of that also. Name of that also we are going to tell, because that's important for the question for the exam. So one thing is clear to you, that this is my primary alcohol. If I add in this oxidizing agent, any of these oxidizing agents, student, supposing you are adding any of these, you can add KMnO4. Then what you are getting? RCHO, and further it is oxidized to RCOH. This is an example of oxidation. ठीक है? Oxidation reaction. And if instead of this I have student this alcohol RCHOHR dash. Which alcohol is this, student?
Secondary alcohol.
2 degree alcohol. Now the oxidation will take place where? There is a hydrogen here, there is a OH here. So what will happen? R C double bond O R. You are getting a ketone. What is the product, student? Ketone. So 2 degree alcohols will give ketones. You can use CrO3. Remember, 1 degree alcohol is giving aldehyde first. And if oxidizing agent is strong, you are further going
Carboxylic acid.
carboxylic acid. And if you have 2 degree alcohol, add chromium
Ketone.
trioxide, you will get ketone. Ketone are not going to oxidize so easily. It's not possible to oxidize it. There is no hydrogen attached to this carbon. There is no hydrogen attached to this carbon. And the question was given like this: CH3, CH3, CH3OH, and they said oxidation. Write the product. or CrO3. What will be the answer, students? In this case, I'm giving only 1 minute. 1 minute for you. Tertiary alcohols. This is a 3-degree alcohols, no oxidation. Let me tell you why I gave this reaction. Tertiary alcohols are not oxidized. There will be no reaction, students. Why? Why? Because there is no alpha hydrogen. There is no alpha hydrogen, student. This is important question has been asked in the paper. So we are making it. You can see that here, this carbon. There is no hydrogen attached to this carbon, only methyl groups. So where is the hydrogen? Nothing. So what oxidation will take place? There is nothing, no hydrogen, so no alpha hydrogen. Therefore, tertiary alcohols are not oxidized. What I am writing, students, tertiary, important, note down, alcohols are not oxidized. The question has been asked in the paper. Because there is no alpha hydrogen, therefore tertiary alcohols will not show oxidation, students. So I hope you have noted down these things. So I will need some cleaning of the blackboard to answer few more questions which are important for the exam. Now we understand what the oxidation means to us, students. I hope you understood the meaning. Primary
Yes, sir.
alcohols on oxidation are giving you aldehydes, which can be further oxidized if the oxidizing agent is strong to carboxylic acid. Secondary alcohol will always give you ketones, student, in the paper if question is given. And tertiary alcohols are not oxidized because there is no alpha hydrogen. Is it clear?
Yes, sir.
Okay, very good. Now let us see which reagent is used to stop the oxidation at a aldehyde stage in the case of primary alcohols. In the case of primary alcohol, student, the problem which we are facing is the aldehydes are very readily oxidized. So what to do, students? Now what to do? This is the important point. What to do? Okay, you are so intelligent, students. You are, देखो, main thing with the student, what you have to do, just focus and concentrate, and then write yourself. This is organic chemistry, and you can get full marks. All my students are getting very high marks in the school papers. Well, you have to focus and concentrate. That's all. And keep on making your notes. They are very important. You have to write in the paper. Therefore, practice is required. Now, what there is a reagent, student. I'm saying batter oxidizing agent. Batter oxidizing agent, student, to prepare aldehydes from 1 degree alcohol, because the problem is 1 degree alcohol is getting oxidized to carboxylic acid. So there is a reagent, student, which is called PCC. I think you will note down this. This is pyridinium chlorochromate. This is called pyridinium Chlorochromate, students. It's a mixture of pyridine. It is a mixture of pyridine chlorochromate, we are saying. Now, what is the important point about this? That this will not oxidize the aldehyde to carboxylic acid. It is made up of CrO3, pyridine, and HCl. It contains pyridine, HCl, and the CrO3. It is made from CrO3. There is a pyridine formula C5H5N and HCl. So we write this is a PCC, pyridinium chlorochromate. When I use this reagent, student, what happens? If I will have CH3, CH2OH, in the paper they write PCC. You have to write the product, students. What is the product then? CH3CHO. That's all. So what is this? Ethanol to ethanol conversion. Ethanol. What you are getting? Ethanol. Interesting thing, if you have compounds which contain double bonds, CH3, CH double bond, CH, CH2OH, and if in the paper they say PCC, the advantage is that other oxidizing agents will break this double bond. They will also attack here, but this doesn't affect the double bond. There is nothing which will happen at the double bond if I use PCC. So in this case, student, what product you are getting? CH3, CH, double bond CH and CHO. So here this is oxidized. Oxidation takes place here, but there is no change in here. The double bond is protected. It is not attacking the double bond, as you can see in this case, students. Therefore, this is a useful reagent. We can do the oxidation and stop at a aldehyde stage by using PCC. This is an important question for the paper. PCC. So if you are given something like this in the paper, CH3, CHOH, CH2, CH3 and CrO3, what will be the product, students? What will be the product? And if you are given CH3, CH2, CH2, OH, KMNO4, alkaline or acidic, and if they say CH3, CH2, CH2, OH, PCC. So you have to write the products in the paper. That's all. You have 1 minute to write these three products. 1 minute to write these three products, students. Organic chemistry, you have to learn the reactions. And you give a correct answer, you get full mark. So no problem. Yeah, if you answer is wrong, then 0 mark. We need practice and we need to learn the reactions. We need to learn the reactions. Some amount of memory is a must because otherwise we will forget. So that is why we keep on writing, students. What is the answer of the first one? What type of alcohol is this? This alcohol is 2 degree.
Secondary alcohol.
2 degree. So this is 1 degree. 1 degree. So this we already know. 2 degree alcohols on oxidation. You can add any reagent. The product will be ketone. The product will be ketone, student. Remember this in the exam. No problem. You can add any oxidizing agent. In this case, what happens if I add KMNO4? If I add KMNO4, student, what is going to happen in this case? What is you are getting? CH3, CH2, CHO. Further, This is a strong oxidizing agent. What will be the final product? CH3, CH2, COOH. Yes. And you have added PCC. What will be the product? CH3, CH2, CH. That's all. So you got it? How do we do the questions in the paper?
Yes, sir.
Okay. So these are examples of the oxidation of the alcohols, and we have given you very clear instructions. Tertiary alcohols are not oxidized. Very important question can be asked. When it is tertiary alcohol, it is not oxidized. Only two alcohols, one degree will give aldehydes or further oxidation takes place. Carboxylic acid 2 degree always gives ketone, 3 degree is not oxidized. Another important reaction is there, students. Another important reaction of the oxidation is there when different alcohols are heated. Another important oxidation reaction we are showing. This was oxidation. Another oxidation reaction I'm saying when different alcohols are, you see, are their vapors are passed over heated copper. Different alcohol vapors passed over heated copper. Heated copper at 573 Kelvin. At 573 Kelvin, what happens? Again, oxidation is possible. These are all examples of dehydrogenation. Yes or no? Tell me.
Yes, sir.
You have heard about hydrogenation?
Ye-
Hydrogenation means addition of hydrogen,
Yes, sir.
where it take place on a double bond, on an unsaturated compound. When you add hydrogen and nickel or any, and dehydrogenation means loss of H2, two hydrogen atoms out. D means loss. So there is a loss of two hydrogens, that is dehydrogenation. So what happens, students? If I take CH3, CH2OH, and you have copper at 573 Kelvin, the dehydrogenation takes place. What happens? Dehydrogenation takes place. Then what is the result? This hydrogen goes, one hydrogen goes from here. What will be left? CH3, CH double bond O. ठीक है? Now if I have CH3, CHOH, CH3, student, you have copper 573 Kelvin. Now where is this? This hydrogen is out and this hydrogen is out. These two. What will be the product then, students?
CH3, C
Uh,
double bond O, CH3.
Okay, very good. Now you have started understanding the chemistry, that you don't have to cram everything. Once you learn it, you know where the hydrogens are out. So this question has been asked in the paper. They have said this copper, write the product. You have to simply write the product. That's all, 1 mark. Now he gives another one. This was like 1 degree, 2 degree. Now we give you 3 degree alcohol in the paper. Students, 3 degree alcohol. And again, students, we are saying copper 573 Kelvin. Then 3 degree alcohol cannot be oxidized. You have learnt it. Then what happens in this case? Elimination takes place. What elimination will take place, student, in this case? देखो elimination किस, what elimination we told you? कौन सी elimination की तुमने, students?
Al-
What?
al- alpha hydrogen की.
Here, what elimination is possible? Students, see what is happening. You have CH3, C, यहाँ पर C है students, C है, C, यहाँ पर भी C है, H3, यहाँ पर OH है. तो व्हाट एलिमिनेशन इज पॉसिबल, देख रहे हैं यहाँ पर OH और OH निकल सकता बाहर. ये निकल जाएगा तो क्या निकला बाहर, ये H और ये OH, if H and this OH goes out student, what is that, minus H2O.
हाँ जी।
आपको पता है कि कुछ some molecules are lost very readily, like water, HCl, carbon dioxide, ammonia. These molecules, nitrogen N2, if they want to leave, they will leave immediately. So heat हो रहा है, water will be lost. It doesn't matter any of these three, all are equal. H from can come from anywhere. OH is there. So what will be the product then, student, if water is lost? Alkene. When elimination takes place, earlier also you have studied. Elimination takes place, student. What happens? You have we have taught you beta elimination. This is our alpha carbon. This is our beta carbon next to it. So what happens? The water will be lost. Then you will get an alkene, student. What alkene you are getting? So you are saying, okay, write the product in the exam. You are putting double bond here, and you have this is CH3, no problem here. So you will get alkene. What you are getting? Alkene. Now you can write it in any way, it makes no difference because all hydrogens are equal. All hydrogens are equal. This is our 1, 2, 3. What is the IUPAC name? 2-methyl. This is what you are getting is 2-methyl. How many carbons in the
Prop।
locus? 3 carbon.
हाँ जी।
Prop in 1 carbon double bond at one position. I don't write. Okay. So these are some of the oxidation reactions which we have discussed, students. Any doubt? You have noted everything?
Yes sir।
Okay. Then we will go further. If you have not noted down, you can note it down, students. These are all examples which we talked of. Oxidation of alcohol was very important reaction, very, very important reaction. They will be asked in the exam. Now it going to come to the reactions of the phenols, student, phenols. Now, when I say reactions of phenols, student, what is a phenol, student? You have OH. This is our phenol. Whenever there is a lone pair, what will is going to happen, student? There will be an effect, you know. We have explained to you what is going to happen. And this lone pair of electron, benzene will immediately, it will act as a sink of these electron, it will take, and there will be a negative charge at ortho and para positions. You have seen that earlier also. What is this called plus R effect? Are you familiar? Any doubt here? Negative charge where? At which positions? Ortho and para.
Para।
You have seen it as resonance structures. Are you sure? Any doubt here?
No sir।
Okay. Now then, what type of reagents will attack if there is a negative charge? Benzene ring. When I say electrophilic, I am talking of electrophilic, students. Pay attention. Pay attention. Electrophilic, aromatic substitution. Electrophile means there should be reagent which has E plus, positively charged reagents. And benzene ring, you are saying there is a plenty of electrons around it. The benzene ring, these pi electrons are there. There is a negative charge at ortho and para positions. So they will attack the benzene ring. They will attach themselves at ortho and para position. Yes or no? Tell me yes.
Yes sir।
Okay, very good. So that means we can do the electrophilic aromatic substitution. These reaction will take place on the benzene ring, and the OH group is ortho para directing group. Ortho para directing group, students, because it is increasing the electron density at ortho and para positions. So one of the reaction which is always asked is nitration. Nitration, students. Nitration of phenol. So what do you do? When you react phenol with concentrated nitric acid and a mixture of sulfuric acid, what are the products which will be formed? Student, what products will be formed? You are aware of these products. This is my nitrophenol. I am writing in the exam concentrated H2SO4 plus concentrated HNO3. What happens when you mix concentrated HNO3 and H2SO4, student? Nitration will take place. What are the products? Then they will ask you, what are the products? And what you are getting? NO2 and second product, para. So you get a mixture of ortho and para nitrophenols, student. Ortho and para nitrophenols are formed. An important question which has been asked, student, is that when you will get ortho and para nitrophenols, how do we separate these mixtures? How do we separate these mixtures? And one of this is steam volatile. One of this is steam volatile, and due to steam volatile they can be separated. What I am saying, orthoisomer is steam volatile. Steam volatile. You know that we can separate the two by a process which is called steam distillation. There is a distillation process. This has a lower. This is more volatile. This is more volatile than paranitrophenol. This is more volatile than paranitrophenol. Or in other words, we are saying orthonitrophenol has a lower boiling point than paranitrophenol. So why? What is the reason for that? So it is steam volatile can be separated. Can be separated. Steam volatile therefore can be separated. ठीक है? Ortho isomer steam volatile can be separated from para isomer. So by means of distillation process, there is a steam distillation, we can separate ortho from para, because the boiling point of ortho nitrophenol is less than para nitrophenol. Now the question, this question has been asked, why? Why is ortho nitrophenol steam volatile, students? What what is your answer, students? Question answer, question answer. This question has been asked in the paper, student. Here actually even this will not be required because it's a very strong reagent. It's a very strong reagent. You will, instead of this, student, what you can do, you can use dilute nitric acid because this will be very strong. Nitration is usually done with concentrated HNO3, but phenol is activated the benzene ring a lot. So I am here writing dilute nitric acid. Nitration will take place with a dilute HNO3 at 293 Kelvin. We are getting ortho and para nitrophenols. If I use a strong reagent, then the three nitro groups will be attached because this OH group is a strong activating group, ortho para. Now what is happening? Nitration is being done with dilute nitric acid. Simply there are mono nitro products, ortho and para. You can see that what is the story here, student, what we want to tell you. this is your orthonitrophenol. ठीक है, this is negative, this is, this hydrogen is positive, this is negative. So what will happen here? There is a formation of, what is this? Hydrogen bonding within the molecule itself. Within the molecule itself, students, you can see what is this? This is an example of intramolecular hydrogen bonding. This is an example of intramolecular hydrogen bonding. So what will happen? The molecule undergoes within the molecule itself, hydrogen bonding takes place. Therefore, the boiling point will become less. It will become more volatile. But in the case of paranitrophenol, what happens? Paranitrophenol, what happens, student? If you see paranitrophenol, let us draw the paranitrophenol, student. You have N double bond O, you have O, and you have OH. Then the more hydrogen bonding are going to take place. Another molecule, another molecule, student. This is our nitro group, OH. You see the OH, this is our N. And what happens here? You can see oxygen and hydrogen. What will they do? They will form intermolecular hydrogen bonding. Intermolecular hydrogen bonding. See the difference? One is intra, this one. One is intra, other is intermolecular hydrogen bonding. Where molecules are now joined together by intermolecular. Therefore, the boiling point of this will be more and the boiling point of this will be less. Clear? Got it?
Yes, sir.
So it will become steam volatile and hence the separation of the two will become possible. Hence the separation of the two will become possible. Student, simply add dilute nitric acid in phenol. You will get two products, ortho and para. And this question has been asked in the paper, which is steam volatile, which is more volatile, and how do you separate them? Therefore, once it is more volatile than this, the boiling point difference is there. It can be easily separated from each other. In the orthonitrophenol, there is an intramolecular hydrogen bonding. In paranitrophenol, there is an intermolecular. Here we have shown this again. This is, we have been shown here the difference between the hydrogen bonding intra and inter. This is an important question, so we discussed it, noted it.
हाँ जी सर.
Okay, then what happens further? What happens, student, further? If I add concentrated nitric acid, then ortho and para positions are highly activated. If you use concentrated nitric acid, student, which I told you in the first case, HNO3 and concentrated H2SO4 mixture, then you will get 2,4,6 trinitrophenol. This is our NO2, NO2, NO2. This we have prepared in earlier reaction also. This is a 2,4,6 trinitrophenol. This is called picric acid. This is a strong acid. There are three nitro groups attached now. Three nitro groups attached, student, 2,4,6 trinitrophenol. ठीक है? So if concentrated acid will be used, these positions are highly activated, and the result of these will be that you will be getting, students, you will be getting 2,4,6 trinitrophenol.
सर,
हाँ
जो हमने सबसे पहले नाइट्रेशन और फिनॉल किया था,
हाँ,
उसमें भी हमने यही दो चीजें
नहीं,
डाली
मैंने
थी.
उसको हटा दिया, दोबारा चेंज कर दिया उसको,
अच्छा, ओके.
क्योंकि उसे ये स्ट्रॉन्ग है, ये बहुत स्ट्रॉन्ग है, इसमें तीनों नाइट्रो ग्रुप लग जाएंगे, तो इसलिए उसको चेंज कर लो, उसे डाइल्यूट कर लो. डाइल्यूट मतलब वीक है ये एसिड, मतलब डाइल्यूट की पावर कम है, कंसंट्रेटेड की बहुत ज्यादा है. तो डाइल्यूट नाइट्रिक एसिड से एक नाइट्रो ग्रुप और कंसंट्रेटेड से कितने लगाए, 3। ये डिफरेंस है दोनों में। इसको चेंज कर लो, मैंने हटा दिया यहाँ से, आई हैव चेंज दैट बिकॉज दैट कंसंट्रेटेड विल प्रोड्यूस 2,4,6 ट्राइनाइट्रोफिनॉल। स्ट्रॉन्ग है, उसकी पावर ज्यादा स्ट्रॉन्ग है, उसमें नाइट्रेशन ज्यादा होगी। यू नो द इलेक्ट्रोफाइल विच इज इन्वॉल्व इन द नाइट्रेशन इज NO2+। कौन सा इलेक्ट्रोफाइल जनरेट होता है, NO2+ बनता है। ये इलेक्ट्रोफाइल बनता है स्टूडेंट्स which is attacking the benzene ring, electrophile. Sometimes they will ask the question, what is the electrophile in this reaction? In this reaction, electrophile is NO2+. तो electrophile कौन सा, NO2+ is the electrophile in this reaction. ठीक है, तो ये नाइट्रिक एसिड एंड सल्फ्यूरिक एसिड दे रिएक्ट टू फॉर्म NO2+, which will attack the benzene ring and form this concentrated nitric acid. Sulfuric acid will give 2,4,6 trinitrophenol. Dilute will give mono nitrophenols, which we have shown here. And they can be, this is steam volatile, this is not steam volatile. इसमें कौन सी हाइड्रोजन बॉन्डिंग है, इंट्रा, इसमें इंटर, यहां भी हमने शो कर दी। ये प्रोडक्ट फिर शो कर दी, कंसंट्रेटेड से क्या बन रहा है, 2,4,6 ट्राइनाइट्रोफिनॉल, तो वो डाइल्यूट से है। तो अब हम इसको देखते हैं हैलोजिनेशन। हैलोजिनेशन कैसे करेंगे स्टूडेंट, अगर हमने देखो क्या किया, फिनोल लिया एंड the OH group has activated the benzene ring, you know, यहाँ पे बहुत फास्ट रिएक्शंस हो रही हैं, इलेक्ट्रॉन डोनेशन बहुत हुआ है। तो अब ये क्या करेगा कि अगर हमने Br2 डाल दिया इसमें, कार्बन डाइसल्फाइड इज अ सॉल्वेंट, इज एन ऑर्गेनिक सॉल्वेंट, यू कैन यूज कार्बन डाइसल्फाइड CCl4, इस तरह से कोई भी डाल सकते हैं। तो हमें दो प्रोडक्ट मिलने वाले हैं, दो प्रोडक्ट मिलने वाले हैं, ऑर्थो एंड पैरा डायरेक्टिंग होती है, आपने देख लिया वो, एक पैरा ब्रोमोफिनोल और दूसरा कौन सा बनेगा, ऑर्थो ब्रोमोफिनोल। दो प्रोडक्ट बनेंगे, पैरा एंड ऑर्थो स्टूडेंट, पैरा एंड ऑर्थो, दो प्रोडक्ट बनने वाले हैं हर बार, देख रहे हैं आप, ये ऑर्थो और पैरा के प्रोडक्ट्स हमने बनाए। तो यहां पर मेजर प्रोडक्ट कौन सा होगा, व्हाट विल बी द मेजर प्रोडक्ट स्टूडेंट, मेजर ये माइनर। ऑर्थो में क्या होता है, यू नो दिस ग्रुप्स दे आर स्टेरिकली मोर क्लोज, सो स्टेरिक प्रॉब्लम। सेकंड, दे आर नेगेटिव चार्जेस, इलेक्ट्रॉन पेयर्स होंगे इनके ऊपर, तो रिपल्शन होगी, इलेक्ट्रॉन इलेक्ट्रॉन रिपल्शन एंड स्टेरिक फैक्टर, दे विल नॉट फेवर ऑर्थो, दे, दिस इज मोर स्टेबल एज कंपेयर टू दिस। तो इसमें स्टेरिक फैक्टर और रिपल्शंस कम है, तो ये मेजर प्रोडक्ट बनता है, ये माइनर प्रोडक्ट बनता है। हमेशा ही हमने दिखाई थी रिएक्शन, पहले भी दिखाई थी, देखी थी। और अगर मैंने ब्रोमीन वाटर यूज कर लिया, Br2 वाटर, ब्रोमीन वाटर होता है, क्या होता है, 3Br2 वाटर, इसे कहते हैं ब्रोमीन वाटर। तो ये सॉल्वेंट नहीं है, तो ये कंसंट्रेटेड है, कंसंट्रेटेड अगर है, ज्यादा है, कंसंट्रेटेड मींस मोर है, तो ये क्या बना देगा फिर, यहां पे क्या बनने वाला है, 2,4,6, तो ये क्या बन गया, 2,4,6 ट्राइब्रोमोफिनोल, तो ये प्रोडक्ट बन जाएगा 2,4,6 ट्राइब्रोमोफिनोल। All these reactions are electrophilic aromatic substitution reactions। तो OH ग्रुप ने क्या किया था कि इलेक्ट्रॉन को डोनेट कर दिया बेंजीन रिंग को, ऑर्थो पैरा ग्रुप एक्टिवेट हो गए, और इसीलिए कि जो इलेक्ट्रोफाइल्स हैं दे आर कमिंग एट ऑर्थो एंड पैरा पोजिशन। इलेक्ट्रोफाइल्स कहाँ आ रहे हैं, ऑर्थो और पैरा पोजिशन पर आ रहे हैं, सभी ही केसेस में आप देख रहे हैं। ये सारी रिएक्शन नोट कर लिया आपने स्टूडेंट्स,
हाँ जी।
अच्छा अब देखो कि बहुत इंपॉर्टेंट रिएक्शंस हैं दो, जो कि पेपर में आती हैं, बार बार आती हैं। एक है कोल्बेज रिएक्शन, ये बहुत इंपॉर्टेंट रिएक्शंस हैं, दे विल बी आस्क्ड इन द पेपर अगेन एंड अगेन स्टूडेंट्स. When phenol is reacted with NaOH, कार्बन डाइऑक्साइड एंड H प्लस, तो होगा क्या कि ये हमारे पास फिनोल है स्टूडेंट्स. फर्स्ट आई विल रिएक्ट दिस इज सोडियम हाइड्रोक्साइड. सोडियम हाइड्रोक्साइड इज अ बेस. ये क्या करेगा फिर, ये H प्लस को, OH माइनस है, इसमें H प्लस है, ये OH माइनस H प्लस को ले जाएगा. तो व्हाट विल बी द प्रोडक्ट, सोडियम फिनोक्साइड, ये बनेगा. और दो स्टेप में मैं कह रहा हूं, इसके अंदर हम कार्बन डाइऑक्साइड होती है CO2 डालेंगे, एंड इन सेकंड स्टेप एसिड डालेंगे H प्लस. क्या डाल लें, H प्लस. अब होगा क्या, ये CO2 कैसे दिखती है, ऐसे देख रहे हो, ये CO2 है और ये नेगेटिव है, ये पॉजिटिव है, ये भी नेगेटिव है. तो ये इलेक्ट्रोफाइल है, यहाँ पे इलेक्ट्रोफाइल दिख रहा है प्लस, ये CO दिख रहा है इलेक्ट्रोफाइल.
हाँ जी.
तो ये जुड़ेगा, ये जुड़ने जा रहा है. ऑर्थो और पैरा दो पॉसिबिलिटीज होती हैं. तो ये ऑर्थो पोजीशन पे हमने प्रोडक्ट दिखाया क्योंकि यहाँ पे हाइड्रोजन बॉन्डिंग हो जाती है, इसलिए ज्यादा स्टेबल प्रोडक्ट है. तो दो दो स्टेजेस में हमने दिखाया है यहाँ पे प्रोडक्ट. तो क्या बन रहा है, OH COOH. इसका नाम बहुत इंपॉर्टेंट है स्टूडेंट. ये कौन, व्हाट इज द नेम ऑफ दिस कंपाउंड. ये बहुत इंपॉर्टेंट रिएक्शन है, बहुत इंपॉर्टेंट रिएक्शन, एग्जाम के लिए बहुत बार आती है. कोल्बेज रिएक्शन. हमने, ये क्या बन गया, ये है 2 हाइड्रोक्सी बेंजोइक एसिड. इसको क्या बोलते हैं, सैलिसिलिक एसिड. इसका क्या यूज किया था हमने, याद है आपने, सैलिसिलिक एसिड से एस्पिरिन बनाई थी. मैंने एक रिएक्शन दिखाई थी ना,
हाँ जी सर.
इसकी एसिटिलेशन की थी. अगर मैं इसको एसिटिक एनहाइड्राइड डाल दूं तो क्या बन गया था, एसिटिलेशन हो गई थी. इसकी हमने एसिटिलेशन की थी, एसिटिलेशन की थी, इसकी एसिटिलेशन की थी स्टूडेंट. तो वो एस्पिरिन बनाई थी हमने. क्या बनाया था, वो रिएक्शन हम ऑलरेडी आपको शो कर चुके हैं. ये कन्वर्शन में बहुत काम आती है क्योंकि एस्पिरिन का बहुत यूज है, पैरासीटामोल वो जो भी आप खाते हैं फीवर के लिए, तो यहाँ पे वो बन जाती है, एक मेडिसिन बन जाती है हमारी. एंड वो फीवर को कम करने के लिए, टेम्परेचर को कम करने के लिए. तो ये जो रिएक्शन है, दिस इज कॉल्ड कोल्बेज रिएक्शन स्टूडेंट. ये कोल्बेज रिएक्शन है. इसमें क्या यूज हुआ है, CO2 H प्लस और NaOH. एक और रिएक्शन है जो बहुत इंपॉर्टेंट है यहाँ पर, वो भी हमने लिखी है, इसके ऊपर भी क्वेश्चन बहुत आते हैं, राइमर टाइमन रिएक्शन. अब इसमें क्या होता है कि वी यूज ए मिक्सचर ऑफ क्लोरोफॉर्म एंड एक्वस NaOH. यहाँ पर हमने क्या किया स्टूडेंट, आपके पास फिनोल और हमारे पास है क्लोरोफॉर्म CHCl3 एंड एक्वस NaOH, इसका मिक्सचर. अब ये क्लोरोफॉर्म क्या है, देखो ये है CHCl. हाँ, ये OH माइनस क्या करेगा, ये इसको ले जाएगा प्रोटॉन को. तो यहाँ से ये एक बन जाएगा, ये Cl बाहर चले जाएगी, तो इसके अंदर ये कार्बीन बन जाती है, कार्बीन बन जाती है CCl. ये इलेक्ट्रॉन डेफिशिएंट होती है, इलेक्ट्रॉन डेफिशिएंट होती है, और ये अटैक करेगी, ये अटैक करेगी यहाँ पर. तो आपको ये प्रोडक्ट पहले मिलना है. इसका मैकेनिज्म हमने अलग से डिस्कस किया है यूट्यूब में, आप उसको पूरा देख सकते हैं. बोथ दीज रिएक्शन मैकेनिज्म आई हैव डिस्कस्ड. कोल्बेज रिएक्शन मेरे यूट्यूब में जाएंगे, कोल्बेज रिएक्शन और रीमन टाइमन का मैकेनिज्म आप देख सकते हैं यूट्यूब पर. तो मैं अभी इसको पूरा यहाँ डिस्कस नहीं कर रहा.
सर आते हैं मैकेनिज्म दोनों के.
हाँ, कई बार ये मैकेनिज्म के चांसेस कम है, पर अगर समझना है तो आप देख सकते हैं. मैकेनिज्म इस बार चांसेस कम है, देखो स्टूडेंट्स इतना नहीं पढ़ पाएंगे, तो आई डोंट थिंक दे विल आस्क वेरी डिफिकल्ट क्वेश्चंस. बट दोज इफ यू वांट टू अंडरस्टैंड हाउ द रिएक्शन टेक्स प्लेस, दिस इज अवेलेबल इन माय यूट्यूब. यू कैन वॉच इट बोथ इन हिंदी एंड इन इंग्लिश मैकेनिज्म, क्योंकि जितनी भी इंपॉर्टेंट रिएक्शंस हैं आई हैव अपलोडेड इन यूट्यूब, उसको आप देख सकते हैं. उसमें मैंने कुछ और भी एग्जांपल दिए हैं, 5-5, 7-7 मिनट ही तो है, उसमें आप देख लोगे, उसमें आपको रिएक्शन समझ आ जाएगी. यू विल अंडरस्टैंड मोर हाउ द रिएक्शन टेक्स प्लेस. देखो ये अपने लर्न करने के लिए होती है, ताकि एग्जाम में क्या होगा कि इफ वी आर नॉट लर्न प्रॉपरली वी विल ना फॉरगेट द रिएक्शन. अगर आप मैकेनिज्म को देख लेते हैं एक बार, तो फिर आपको समझ आ जाती है कि रिएक्शन कैसे हुई है, फिर आप उसको ना लर्न कर लेते हैं, फॉरगेट नहीं करोगे एग्जाम में, इसलिए कह रहा हूँ।
ओके सर।
5-7 मिनट का होता है वो लेक्चर, तो आप उसको देख लो। उससे क्या होगा कि ये आने वाली पेपर में मैं बता रहा हूँ, ये इंपॉर्टेंट है इसलिए बता रहा हूँ, इस तरह से ये स्टेप्स दिखा रहे हैं इसके। H+, तो H+ से फिर क्या होगा, ये बना ONA, और यहाँ पर हमने ये CH Cl2 बना था पहले, ये देख रहे हो, CH Cl2 यहाँ लगा था, ये वाला, और फिर NH डाला तो ये CHO बन गया यहाँ पर। अब H+ से इसको रिप्लेस करेंगे तो व्हाट यू विल गेट, OHCHO। वहां पे सैलिसिलिक एसिड बना था, यहाँ पे सैलिसिलिक एल्डिहाइड बन रहा। व्हाट यू आर गेटिंग, सैलिसिलिक, इंपॉर्टेंट रिएक्शन है, ये इंपॉर्टेंट रिएक्शन है, यहाँ पर हमने शो की है, यहाँ पर भी हमने ये शो की है, कोल्बेज और रीमर टाइमन, ये दोनों इंपॉर्टेंट है स्टूडेंट्स। तो इनका मैकेनिज्म आप देख सकते हैं, वो हमने पूरा का पूरा दिया है। इट हेल्प्स यू इन द लर्निंग द रिएक्शन। तो हम लर्न कर सकते हैं कोल्बेज रिएक्शन, रीमर टाइमन रिएक्शन, और उसके बाद में हम ये कर रहे हैं कि जब नेक्स्ट रिएक्शन जो है फिनोल की, ये भी हो गई आपकी, व्हेन फिनोल इज रिएक्टेड विद जिंक डस्ट, फिनोल को जिंक डस्ट से रिएक्ट कर देंगे स्टूडेंट, तो बेंजीन बन जाएगी। इज इंपॉर्टेंट रिएक्शन। क्वेश्चन वाज कन्वर्शन ऑफ फिनोल इनटू बेंजीन, क्वेश्चन इज इन कन्वर्शन ऑफ फिनोल इनटू बेंजीन स्टूडेंट्स, एग्जाम में। तो यहाँ पे जिंक ऐड कर दो तो बेंजीन बन जाएगा। जिंक डस्ट, जिंक के क्या करता है, ऑक्सीजन को खींच लेता है। जिंक क्या करता है, ऑक्सीजन को ले जाता है। जिंक ऑक्सीजन को ले गया तो खुद ऑक्सीडाइज हो गया, तो ये रिड्यूसिंग एजेंट है। जिंक इज ए गुड रिड्यूसिंग एजेंट, यू ऑलरेडी नो अबाउट दैट। तो जिंक ऑक्सीजन ले जाएगा यहाँ से, तो क्या बन जाएगा, बेंजीन। तो इस तरह से यहाँ पर इफ यू हीट फिनोल विद जिंक, हीट फिनोल विद जिंक स्टूडेंट, तो बेंजीन बन जाएगी। ये भी नोट कर लो, इंपॉर्टेंट रिएक्शन है, ये भी एग्जाम में पूछी जा चुकी है। कन्वर्शन ऑफ फिनोल इनटू बेंजीन मैंने लिखा है, इसको नोट कर लो। अब लास्ट रिएक्शन दिखा रहा हूँ, ऑक्सीडेशन फिनोल की। अगर स्ट्रॉन्ग ऑक्सीडेशन कर दी जाए, सोडियम, ये हमारा सोडियम डाइक्रोमेट और सल्फ्यूरिक एसिड से, तो बेंजोक्विनोन बन जाता है, इसे बोलते हैं बेंजोक्विनोन। ये फिनोल था, इसको हमने ऑक्सीडाइज कर दिया है स्टूडेंट्स। तो Na2Cr2O7 सोडियम डाइक्रोमेट है, H2SO4 है, ये एक ऑक्सीडाइजिंग एजेंट है। जस्ट लाइक जो आपका ऑक्सीडाइजिंग एजेंट था पोटेशियम डाइक्रोमेट, सोडियम डाइक्रोमेट भी ऑक्सीडाइज कर देगा, तो क्या बन जाएगा, बेंजोक्विनोन कहते हैं इसको। द नेम ऑफ दिस स्टूडेंट, बेंजोक्विनोन। देखो ऐसे प्रोडक्ट एग्जाम में कई बार पूछे गए हैं, दिस गिव द प्रोडक्ट, तो दिस इज कॉल्ड बेंजोक्विनोन। तो बेंजोक्विनोन बन गया, ऑक्सीडेशन हो गई, ऑक्सीडेशन हो गई। तो दीज आर सम ऑफ द मोस्ट इंपॉर्टेंट रिएक्शन विच वी हैव डिस्कस्ड। इनमें से क्वेश्चन आएगा पेपर में। कोल्बे रिएक्शन, रीमर टाइमन, कोल्बेज रिएक्शन में बना सैलिसिलिक एसिड, यू रिमेंबर। रीमर टाइमन में बना सैलिसिल्डिहाइड। और याद करने का तरीका कि जो रीमर टाइमन है, इसमें क्लोरोफॉर्म और एक्वस NaOH का यूज होने वाला है। क्लोरोफॉर्म और NaOH का यूज होना है रीमर टाइमन। और उसके अंदर क्या यूज होना है, कोल्बे रिएक्शन में कार्बन डाइऑक्साइड और H+ का यूज होगा, NaOH पहले स्टेप में, फिर कार्बन डाइऑक्साइड और H+। तो यहाँ पर जो सारी जो रिएक्शन हमने दिखाई हैं वो कौन सी थी, इन सब में क्या हुआ था कि आपके सामने जो रिएजेंट बेंजीन के ऊपर अटैक हुए हैं वो इलेक्ट्रोफाइल्स थे। तो ये सब इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन रिएक्शन है, जिसको हमने एक्सप्लेन किया है। कौन सी रिएक्शन, इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन। ठीक है, फिर ये खत्म हुआ, और फिर हम आपको मिलेंगे नेक्स्ट लेक्चर में। आप इन सबको नोट कर लो, इनका मैकेनिज्म आप देख लो, ये बहुत अच्छा है, काम आएगा एग्जाम में। ये रिएक्शन आने वाली है, बहुत इंपॉर्टेंट है, दोनों में से एक आएगी। तो इनके प्रोडक्ट्स कैसे बने हैं इनको समझ लो, ठीक है।
ओके सर, थैंक यू सर।
ओके।